everyone, I am here along with my team. Today we are here to present the TA activity of digital electronics. Our topic is implementation of error correcting Hamming code. So throughout this presentation we will go through the following topics. First is what is Hamming code, then the error correction of Hamming code, then we will move towards the truth table and K-map, and finally we will see the implementation. So firstly let us understand what is the Hamming code is. Hamming code is an error correction system that can detect and correct the errors when the data is stored or transmitted. It requires adding parity bits. Now the figure shown here represents the error correction of Hamming code. By making use of all these concepts, we can be able to calculate the error correction of Hamming code. So here we are given with the 7 bits, which are D7, D6, D5, D3 and P4, P2 and P1. So let us see that how to calculate the parity bits. P4 is the even parity of D7, D6 and D5. P2 is the even parity of D7, D6 and D3, and P1 is the even parity of D7, D5 and D3. By making the use of this concept, you will be able to calculate the error correction of Hamming code. So this is the truth table for the Hamming code. Next is the K-map for P4. Here we had shown the K-map for P4 by solving the equation that can be made by this K-map. We will get the following equation: P4 equal to D7 XOR D6 XOR D5. This slide shows the K-map for P2. By making all the useful operations on the given K-map, we will be given with the following equation, which is P2 equal to D7 XOR D6 XOR D3. And last but not least, this is the K-map for P1. By solving this K-map, we will get the equation for P1, which is P1 equal to D7 XOR D5 XOR D3. This is the implementation of Hamming code generator. So what we are doing here is, firstly we are taking D7 and D6 as the input. We are passing them through the XOR gate. Then we will get, then whatever output will be obtained is again passed through another XOR gate along with the D5. Here we will get the output as P4 equal to D7 XOR D6 XOR D5. Next is, we are taking another XOR gate and passing the output of the first XOR gate, which is obtained from the input D7 and D6 and along with the D3, and we are passing these both inputs in the another XOR gate, and we are getting P2 equal to D7 XOR D6 XOR D3. And in the last condition, what we are doing is, we are taking the D7 as input and D5 as the input in XOR gate, and whatever output is obtained is again passing through another XOR gate along with the D3. Then our output is P1 equal to D7 D5 D3. Our output will be P1 equal to D7 XOR D. So
for the Hamming code implementation, we required breadboard, 7486 XOR 2 IC, wires, resistors and 3 LED. This condition D7 is 1, D6 is 1 and D3 is also 1, only D5 is inputted as 0, hence our P4 is 0, P2 is 1 and P1 is 0. Now at this condition D7, D6, D5 and D3 all inputs are 1, hence all the outputs P4, P2 and P1s are 1.